Hey students, so we're going to do the last section of chapter 10, which is complex numbers. Complex numbers are a result of square roots, where we have a negative inside of a square root, which you were told we can't have, but we can. We just have to expand what we allow as a number. So let me share your screen and kind of explain some stuff about how numbers are organized. So there's a bunch of different types of numbers. And really all we've worked with are real numbers, right? There's the natural numbers, which is everything, all the integers 1 and up, right? Things that you can actually count that exist, right? Zero things don't exist, so they're not actually included in the natural numbers. Then there's the whole numbers that include 0. Then there's the integers, which is probably what you guys are very familiar with. Those include negative numbers, but they're all, solid numbers. Then there are rational numbers. Those are things that can be written as a decimal or written as a fraction. And these numbers, as I'm going, they include all the numbers below them. So there's rational numbers, okay? Then there are irrational numbers. Irrational numbers are like square roots that don't simplify, pi, they're numbers that exist, but they can't be written with a finite number of decimals or as a fraction. All of these numbers encompass what we call the real numbers, okay? They're all real numbers. But now we're going to add to that another type of number, and that is where part of our number has the square root of a negative, specifically the square root of -1. These are called complex numbers because they are real numbers and they have an imaginary part. That imaginary part is the square root of -1. It's possible that you have, say, square root -4 or square root -3 or something like that. We factor out the negative as a -1 so that you look at the square root of the number separate from the square root negative part. So the imaginary unit is represented with the letter I, and anytime you see the letter I, that means the square root of -1. Okay. If you have a square root of any other negative number, we factor out the -1 times the positive part of the number. Okay. So anytime you see the square root of a negative, we know we can't actually do that, right? Because no number squared would give you that. So we don't know what that simplifies to. We call that an imaginary number. And when that gets added to a real number, it's a complex number. Okay. So now we're going to start working with complex numbers and imaginary numbers. And they're not too complicated. You just have to keep your negative sign straight, really. So here's some examples. I'm going to show you how to write these guys using the imaginary unit I, and how to do stuff like this multiplication and this addition and this multiplication here using that imaginary unit I. So we'll do our first example, which is the square root of -16. All right. What we want to do here is separate the negative part from the rest of the number. So we're going to rewrite this as the square root of -1 times 16. And then we can rewrite that as the square root of -1 times the square root of 16. Okay. Now we know the square root of 16 is 4. And the square root of -1 is our imaginary number I. So we're going to call this 4I. That's what this number is. 4I is 4 times the square root of -1. Okay. Let's do another example. If we have negative square root -20. We're going to do the same thing. We're going to factor out that square root of -1 from the square root of the 20. So we've got negative square root of 20 times square root of -1. Now 20 is 5 times 4. So we can take that square root of 4, it pulls out a 2, and we've got a 5 inside. And then we're still multiplying by the square root of -1, which is an I. But let's write everything that's not in the square root in front of the square roots. So we've got negative 2I root 5 here. That's how we would rewrite it. Okay. And if you're just a little confused, this 20, remember, is 2 times 2 times 5. So square root of that 2, and that's how I got this 2 root 5 here. All right. So that's how you deal with the negative sign inside the square root. You factor it out as a -1, which then becomes an I. All right. Let's take a look at one more example, or a few more examples actually. Now, what if we wanted to multiply two square roots? The product rule does not hold for imaginary numbers. So before you do anything with these two factors here, you have to see that we've got the square root of a negative, and that needs to be taken into consideration before we do any other simplification. What I mean there is that we have to factor off the square root of -1 before we use the product rule here. All right, so when I factor out that square root of -1, those both become i's. So we end up with the square root of 4, square root of 9 times I, okay? Because both of these guys turned into our imaginary number I. And now we can say, but the square root of 4 is 2, and the square root of 9 is 3, and I times I is going to be I squared. And 2 times 3 is 6. So we've got 6I squared, right? But what's I squared really mean? I is the square root of -1. So if we've got the square root of -1 squared, we just have a -1. And -1 times 6 is -6. So this whole thing simplifies to a -6. All right. That's the correct way to do it. Maybe you're wondering, couldn't we alternatively just say square root of -4, square root of -9, use the product rule? That's the square root of -4 times -9. Double negatives become a positive. We get the square root of 36. We get. No, we can't do this. The product rule does not hold when we have imaginary numbers. These guys are imaginary, right? Anytime you have a negative under a square root, that number is not real. So it doesn't follow the same properties as all our real numbers. So because these are imaginary numbers, the product rule doesn't hold. All right, so it is not 6. The answer is -6. And notice what we did here. We were not able to use the product rule until after we separated our imaginary numbers off. So now our imaginary numbers are here. And then it is okay to use the product rule with these two real numbers. Okay, if we wanted to. So notice the difference in signs there. The product rule doesn't hold for imaginary numbers. If you try to use it with imaginary numbers, your sign will be incorrect. Let me show you how we add and multiply some more stuff. All right, so here's an example of two complex numbers. This thing here is a single complex number. It's complex because it has a real part and an imaginary part, so we call it complex. And this is another complex number over here. We're just going to add these two complex numbers. Sometimes when you see two numbers in parentheses like this, you assume multiplication, but notice there's an addition here. We're just adding these two complex numbers, okay? And when we add complex numbers, we just add the real part. We're going to add the 3 and the -4, and then you add the imaginary part. We're going to add the -5i and the I, okay? So when we add our real parts, we get a -1, and when we add our imaginary parts, we get a -4i. So we can rewrite it as -1 minus 4i. All right, that's how we add imaginary numbers. We just add the like terms, which is adding the real part, adding the imaginary part. If they're negative, if you're doing a subtraction, same thing. All right, that's adding complex numbers. Let's multiply some complex numbers. So in our next example, we've got this complex number 2 minus 5i. And we've got this complex number 4 plus I. It looks similar to the last example, but here there is no addition in between them. So this is multiplication. All right. So when we multiply, remember all the terms in the first set have to be multiplied by all the terms in the second set. So we've got 2 times 4 is 8. 2 times I is 2i. We've got -5i times 4 becomes -20i, and we've got -5i times I is -5. I times I is I squared. -5i squared. And now let's remember what I squared equals. I squared is the square root of -1 squared, which is just a -1. All right, so this piece here becomes -1. And then we can combine our like terms. We've got an 8 and 2i minus 20i is going to give us a -18i. And then this thing here, -5 times I squared is -5 times -1, which is a +5. When I add that +5 to the 8, I'm going to get 13. And we've still got the -18i. So even though we multiplied these two things, because the I simplifies the way it does, we just end up with another complex number. Okay. Let's take a quick look at how the powers of I work out for us. So we know that I is equal to the square root of -1. And as we saw, I squared is going to be the square root of -1 squared, which just becomes a -1. All right. Now let's see what I to the third does. Square root of -1 to the third is the same thing as the square root of -1 squared times the square root of -1. Okay. So here, the square root of -1 squared is just -1. So we've got -1 times -1. So that's going to give us -I. Okay. Right. And then let's go I to the fourth. That's the square root of -1 to. We could write that as the square root of -1 squared times the square root of -1 squared. That's going to be -1 times -1. That's going to be a +1. All right. Then we can do I to the 5th, and you'll see how our pattern starts to repeat. I to the 5th, square root of -1 to the 5th. Well, that's really square root of -1 to the 4th times the square root of -1. But we know square root of -1 to the 4th is just 1. This whole thing is just going to be square root of -1, which is, again, I. And our pattern repeats. Right? So I is I squared is -1, I to the 3rd is -I to the 4th is 1, I to the 5th is just I again. So you can imagine if you wanted to know what I to the power of 6 is, well, that's going to be -1 because that's just our pattern repeating. So I, -1, -I, 1. I, -1. And that is how the powers of I work. So if you do get to any higher powers, you can work through that. All right. All right, guys, that is everything for 10.7 complex numbers. Good luck on this section. Definitely, if this seems really simple, make sure you're being very careful when you're dealing with the powers of I and not using the product rule for imaginary numbers. Okay, you have to separate that I and use the powers of I the way I've shown you here. All right. Good luck with that. And if you have any questions, go ahead and post them in the discussion. Thank you. Bye.